So let's start. First of all, a very good evening to everyone. So in today's session, we'll be seeing a problem statement, which is a plate with a hole. We'll be seeing how you can perform an analysis on a 2D geometry. So you'll get down the process as well as you'll get down uh, some parameters of how you can measure geometry. So before moving forward, I want everyone to take down this problem statement. So everyone just take down the problem statement which you can see on the screen. Once you take down this problem statement, just reply to me that you have done so that I'll explain you about this problem statement. So everyone just take down the geometry and the inputs. Everyone just reply once you're done so that we can move on. I need a reply from everyone. Okay, so I've got a reply from almost all of them. Now I'll just explain you this problem statement. So in this problem statement, we'll be creating a plate which will be having the hole at the center, and the dimension of the plate is been given over here. So the radius is 50 mm. The thickness what we need to consider for this plate is 10 mm, and these are the material properties what we are going to use. So from this material properties itself, you must be getting one idea that the material which we are going to use is steel, and this is the total force what we want to put on towards one side, and this is the side where we are going to constrain our geometry. So this is the edge where we are going to constrain our geometry, and the dimension of our plate is 1000 mm by 1000 mm. Fine. So now let's see how you can create this geometry and how you can solve this problem statement. Now at the end of this problem statement, let me clear one thing. What we will be getting to know after solving this and after seeing the results, we'll be trying to mesh this geometry by using different elements, like these element shapes which we'll be using will be quad elements, tri elements, and we'll be seeing the difference between how the element size or the element shape, if it is changed, then how are the results going to vary with respect to the size and shape of the elements. So at the end, you'll be coming to know how the element size and the shape of your elements are going to affect your results. So the theory what we have learned during the 2D theory when we have seen, so those parameters or those concepts which you have learned regarding how you need to mesh, if you are using a quad element, why is it good to use a quad element, how far away results your tri elements are going to give with respect to the actual results. So all these things we will be coming to know at the end of this session. So if I just calculate the stresses because of the loading condition for this geometry, the stresses what I'm going to get is 3 MPa. So if you just calculate the analytical stresses for this particular geometry according to the same loading conditions what you have taken down, then I'm going to get the maximum stress analytically if I'm solving it as 3 MPa. So we'll see how results or what are the results we are going to get by using different element shapes and sizes. Okay, so now this is the problem statement which you are going to get as a homework. So we are going to take the same examples which you're going to solve as a homework. So let's start with it. We'll be starting with the first problem in which we need to mesh our geometry by using quad element of first order. As you must have seen during the theory that we have something that is first order and second order elements. So we'll be solving first problem statement by using first order elements, first order quad elements, and the element size is also mentioned. The element size which we are going to use is 100. So now let's move on to the software. Before going to the software, everyone just reply that can we start on the software? Have you done with all the things which I have asked you to take down? If no, I can stop for some moment and then we can continue with the software. Akshat says that I'm not audible. Akshat, am I audible to you now? Okay, fine. So is the volume clear to you now, Akshat? Okay, so let's move on. Now, everyone, just reply to me the standard process what you have taken down when you need to solve any 1D problem statement. So you have taken down, or you must have taken down, a process how you can prepare a solver deck. You must have taken the initials of the how to create the solver deck. So everyone just reply what is that process what you have used for 1D. Yes, Natarajan, I'm asking about the same thing which you have replied. Yeah. Okay. So almost everyone has given me the answer. Yeah, and all of them are correct. That the process what you have seen to solve a problem statement for 1D static structural type of analysis is M H P C L L. So this was the process what we have seen if you're having a geometry in 1D. Since we are doing 2D, we'll be using a different code for 2D or for 2D. You can just take it down. That is MPCLL. This is for 2D. Now I have a small question. When we used to solve a problem statement in 1D, you had something that was H, which we are not going to use during 2D. So can anyone just answer me, or everyone just answer me, that why I'm not going to use H in 2D now? Why I'm not going to use H? Or what does H signify? Okay, yes, most of them are giving the right answer, that H is used when we need to define the cross section of our geometry. Here today we are going to use a 2D geometry. That is, we'll have to define the thickness, and thickness will be defined in some other at some other stage. So for thickness we don't need to call H or hyperbeam. So we won't be using H today. That will be used to define the cross section. Fine. So let's move now. First of all, as our process says, I'll have to create a material. So let's go to material icon. So this is the material icon. Let's go to material and name the material. I want to give the material name as mild steel. I'll select a color, type as isotropic, and I'll use the card image mat1 and say created it. So I'll just activate E, new and row, since the properties which we are having over here by default is for the steel. So I won't be making any changes in this values, and I'll say return. So now you can see over here that we have created a material. Now the next process is we'll go to property. In property I'll select the create radio button, that is I'm creating a new property. I'll name the property as, let's say, pwh underscore prop. Type is 2D. Card image what we'll be using over here is p shell. So I'll be using the p shell card image, and in the materials I'll select the material which I've created over here, that is mild steel. So I'll select mild steel. So now once you're done till here, we'll go to create edit. Now by using create edit, I can give the input for the thickness which we are having over here. So the thickness for my geometry is 10 mm. So I'll be giving the input for thickness, that is 10, and say return. Return. Now you can see that the property has been created. Now the next thing I'll have to do is I'll create a component. So let's go to component icon. I'll select create radio button. Component name, let's name it as PWH, that is plate with hole component. I'll just change the color. We'll say no card image, and in property I'll select the property which I've created right now before entering into components. So I'll select the property and say create. Return. So we are done with M, P, C. Next thing is L, that is load collector, and after that we have one more L, that is load step. So before going to load collector, in load collector we need to give the boundary conditions, that is we'll apply the force, we'll apply the constraints. But to apply the force and the constraints, we'll have to create an element first of all, and the nodes. And before creating the elements and nodes, I'll have to create the geometry. Because we are not having a geometry, I'm going to create the geometry over here itself. I'm not going to import the geometry. So to create the geometry, I'll just create a node first of all, which I can give it as a base for my geometry. So I'll go to geometry page, nodes panel. So as you can see over here, here we have the nodes panel. So we'll go into nodes. I'll select the first option, that is XYZ, where I'll be giving the coordinates for the location where I want the node. So I can give it as anything. Since I'm just taking it as a base, I'll give it as 000 and say create. So now you can see that we have got a node over here. Just to bring this node at the center, I'll press F from the keyboard. So if you press F, it means that it will make fit to screen. So I'll just press F from the keyboard. So return. Now I'll be creating the surface geometry for the plate. For that, I'll go to surface panel. I'll stay in geometry page and I'll go in surface panel. So once I go to the surface panel, I'll select this first icon by which I can create a surface. I'll have to give the base node. It is asking me for the base node. So I've created the base node which will be acting as the center of my plate. So I'll select this node and I'll select Z axis. Remember that this Z axis means it is the perpendicular axis to the plane in which you're going to create your geometry. So I'm going to create my geometry in XY plane. So the perpendicular axis to XY plane is Z axis. So I'll select Z axis over here and give the size as 1000, since we can see in the problem statement that the dimension for my plate is 1000 mm by 1000 mm. So it is a square plate. So I'll give the size as 1000 and say create. Now if you are not able to see this plate which has been created, just press F from the keyboard again. So now you can see the outer edges of the square. Right now it is in wireframe mode. So right now it is in wireframe mode. We'll just put it into shaded geometry mode so that I'll be able to see the surface geometry which I've created. So let's select the option of shaded geometry. So now this is the geometry which I wanted to create. Now further, I need a hole at the center. So anyways, I'm having a node at the center. Now to create a hole, we'll go to lines panel and first I'll draw a circle of the radius or the diameter what we have as an input. So by using that circular line, I'll just trim the surface geometry. So first of all, I'll have to create a circle. So for that, we'll go to lines panel. We have an option over here to create a circle. So I'll just select that option. It is asking me for the node list. So I'll give this node as an input. Radius is 50. So let's enter it as 50 and say create. And say return. So now you can see over here that we have got a line, a circular line. So with respect to this line, I'll just trim the geometry. For that, I'll go to surface edit panel. In surface edit, I'll select trim with lines radio button. I'll go to with lines. In surface, I'll select the surface which I want to trim, and in lines, I'll select the line which I want to, with respect to which I want to trim my surface, and say trim. Say return. And now to delete, I'll go to the delete icon. So here I'll be deleting this inner part which I don't need. So I'll go to delete. I'll select this inner surface which I want to delete. Say delete entity. Say return. Now I've got the geometry which I expected. So now for the further step, I'll have to mesh this geometry. So to mesh this geometry, we'll go to 2D page. So now I'll select the 2D radio button, that is the 2D page, and we'll go to auto mesh panel. So let's go to auto mesh. Here it is asking me to select the surface. Make sure that you're into size and bias option. So today we will be seeing this size and bias. In the further classes, we'll be seeing the other options which you can see below size and bias. So for today, let's concentrate on the first option, that is size and bias. So I'll be selecting the surface on which I want to create the elements. If you see the problem statement, I want first order quad elements of element size 100. So I'll enter the element size as 100. From mesh type, you can just go to the drop down and select quad elements and keep rest of the options as it is. This, this option and this option. Just keep it as it is. We'll see in the further sessions or in the further part of today's session what the other option does, and say mesh. So the software has created a mesh according to the element size and the element shape which I've selected. Now let's say return. Return from here also. So now you can see the geometry in the shaded form. Now for the further part, I'll have to create a load collector. So let's go to the load collector icon. Since I was just waiting for the elements and the nodes to get created so that I can go to the further step after component, that is the load collector. So now we'll go to the load collector and I'll create a load collector, that is SPC. I'll give a color to it. In card image, I'll select no card image and say create. So you can see over here that we have created a new load collector in the name of SPC. I'll be needing one more load collector, that is to apply the force. So immediately I'll just create one more load collector and keep name it as force. Let's change the color for force and say create. Return. Now to define both of these things, I'll have to go to analysis page. So I'll go to analysis page and let's go to constraints. We'll go to the constraints panel Here I'll select the nodes on which I want to apply the constraints. So I'll just make a window selection. To make a window selection, if anyone doesn't know, you'll have to press shift from the keyboard and the left mouse button and just drag the window. So whatever nodes comes under that window will be selected. And before selecting create, you can see over here that right now force has been highlighted. So if I'm creating any of the constraints, those will be going under the load collector, that is force. I don't want that thing. So I'll just make a right click on SPC and say make current, and then I'll say create. So the SPC have been created, but the icon is small. I'll just increase the size. So now you can see that the constraints have been created. Now further, I'll define the force. So to define the force, I'll go to analysis page, forces panel, and I'll have to select all of these nodes. Okay, Karthik says that repeat the selection process of nodes. Okay, I'll repeat the selection process for the nodes. I'll just show it to you once again. We'll go to the constraints panel. I'll do the window selection. So to do the window selection, I'll press shift from the keyboard and press left mouse button and just drag the window. So whatever nodes are getting selected inside that window, those are the nodes on which the constraints will be applied. So once you say create, the constraints will be created. After that, you can say return. Let's go to force. So now to apply the force, yes, Karthik. So now to apply the force, I'll have to again select the nodes on which I want to apply the force. So now once I've selected the nodes, you can see it says that 11 nodes are added at the left bottom corner. You can see that 11 nodes are been added. That is, there are total 11 number of nodes on this edge. So now what I'll have to do is I'll have to divide the total force of 10,000 Newton by 11. So if I just make a division, you can make the division at your end. I'll make it at my end. The value comes around 909.09. So this is the value what we are going to get if I divide it with 11. But the thing is that if I'm going to apply the same force on each and every node, what will happen is when I'm going to see the output, I'll get the output in somewhat this manner. So if I'm going to apply the force of 909.09 Newton on each and every node, this is the deformation pattern what I'm going to get. But this is not expected. What I want is this force should be uniformly distributed along the whole edge. So in that case, what we'll do is on this particular nodes, which are the inner nodes, I'll be applying the force of X Newton, and on the end nodes, which you can see at the vertex, I'll be applying the force, that is x upon 2. This is because of some reasons. I'll tell you the reason. Here if you see, this node and this node are going to get the reaction or the resistance from this element. There is only one element which is going to provide the resistance for the load what I'm going to act at the vertex nodes. But if you see other nodes, the other nodes are having two elements in total to share the resistance of the load what is going to come on that particular node. So what we'll do is, for the inner nodes we'll be applying the magnitude of force as x. Let's consider that variable as x for now. And on the outer, that is the vertex nodes, we'll be applying the load of x by 2. So ultimately what we'll do is, if this is the total load, I'll divide it by 11 minus 1, that is 10,000 divided by 10, which comes to 1000. So I'll be applying 1000 Newton of force on the inner nodes, and I'll be applying 500 Newton of force on the outer nodes. So is this thing clear with everyone? Please just reply to me. I need a reply from each and everyone. Okay. So some of them have got a question that why 11 minus 1. Fine. So this total number of nodes are 11, and the load what I'm going to act on this node and this node is half the load what I'm going to act on the inner nodes. So if I count the number of nodes what I have inside, that is 9. 9 plus 1 by 2 of the top node and plus 1 by 2 that is at the bottom node. So it ultimately becomes 10. So I'm going to divide 10,000 by 10 instead of 11, because I'm going to distribute the load, or I'm going to put the load of half magnitude. So am I clear to some of them who have asked this question? Okay, Karthik has asked me the question. He says yes, it is clear now. Saurabh also is clear with it. Okay, good. So now let's move further. So in this case, what we'll do is I'll just deselect these two nodes, and first of all I'll apply the load on this 9 nodes, that is of 1000 Newton. So I'll give the magnitude as 1000. The load will be acting in x direction. So I'll put x axis. I'll say force as make current. I'll give the size as 1 and say create. Okay. See, the load has been applied. I'll just increase this size. So now you can see that I've applied the force on this 9 nodes. Now in the same way, I'll select the outer nodes and apply the force of 500 and say create. Okay, so now I'm done with the load collector part. Now the last step is the load step. Now I'll stay in the analysis page itself. We'll go to load step panel. I'll name this load step as, let's say, type will be linear static. I'll assign SPC in SPC, and under load I'll apply this force and say create. So I've created a new load step now. So return, and we'll solve this geometry now. Now we'll solve this problem statement, but before solving, let me just save this file. Save. Okay. So now we'll just run the solver. Optistruct, Optistruct. We'll select the contour option. From result type, I'll select the stresses and say apply. Select simple in averaging method, say apply. So now as you can see that the maximum stress what we are getting is 1.116 e to the power 0 MPa. But the actual analytical result what we have got is 3 MPa. So this means that if I'm using the element size of 100 on this particular geometry, I'm going to get the result very much far away from the actual result. So now let's change the element size. Let's make the element size more small. We'll take the element size of 50 and try to solve it again. We'll just delete all of these elements, return. I'll go to 2D page, Automesh panel. I'll select the surface. I'll give the element size as 50 say mesh. So now this geometry is been meshed by using the element size of 50. So now you can see that there are small elements which have been created as compared to the previous size of elements. Return. Now I'll go to analysis page, constraints panel. I'll apply the constraints and the force again. So these are the nodes where I want to apply the constraints. Let me make current the SPC option and say create. We'll go to forces. So if you see the total number of nodes in this case, we are having it as 21. So if you see at the left bottom of your window, there are 21 nodes which are getting selected. So ultimately I'll have to divide 10,000 by 21 minus 1, that is 20. So I'll divide 10,000 by 20. So it will come as 500. So I'll apply 500 Newton of force for this inner nodes and say create. And at the outer nodes, the load will be 250. Create. So return, and I'll just run the file. I'll save this file and let's run the solver. Okay, so now let's check the result. In the result type, I'll select stresses. Averaging method, I'll select it as simple. Apply. So now if you see the stresses, the value has been increased. In the previous results, we are getting the value of maximum stress as 1.16, and now as I'm going to change, or as I've changed the element size from 100 to 50, that is I've increased the number of nodes. And as we have studied that if we increase the number of nodes, that is if we increase the calculation points, we'll be going more close to the actual results. So that is the thing what I've got. As well as with that value of maximum stresses, you can see that the distribution of the stress is also being changed. So this is more accurate, or this stress distribution is more accurate, you can say, as compared to the previous one. It is not the exact output what we want, but it is just better than the previous one. So now in the same way, we'll select the smaller element size. Let's go to 10. Before that, we have a question. So how can we know that we have to take one particular element size? Okay, I'll just answer a question. Just give me some time. Let me finish off with this thing first, and then I'll answer the question. Now I'll be using the element size of 10. I'll just delete all of this previous elements. Return. I'll go to AutoMesh. Select the surface. Select the element size as 10. Mesh. Return. Analysis. Constraints. return. I'll go to forces. There are 101 nodes getting selected. So I'll have to apply 100 Newton of force at the inner nodes, say create, and at the outer nodes, the magnitude will be 50. Return, save, run the solver. Okay, so till the output window is getting open, let me answer the question. Sai Kumar has a question that how we can know that we have to take one particular element size. Uh, yes, actually, Sai Kumar, this homework is to answer your question itself. So the homework what we are going to solve for this plate with hole is for the same reason, so that you people will be able to know how and what element size or what element shape you'll have to select on the particular geometries. Actually, it is not a direct process, it is an iterative process. So you'll have to iterate and see what element size is giving you good results. So accordingly, you can just select the element size according to it. Okay. So now here you can see that we have went more close to the actual result. The actual result or the analytical result which we have calculated is 3 MPa, and by using the element size of 10, we have got the result as 2.469 MPa. So which is more close to the actual result. So now in the same way, you'll have to solve this problem statements, the number of nodes and the number of elements you'll have to enter in this two columns, and the stresses you'll have to enter in this column. I've shown you how you can see the stresses. Now I'll just show you how you can see the number of nodes and the number of elements. So to see the number of nodes and elements, you'll have to go to tool page. So we'll go to tool. In tool page, you'll have to go to count panel. So let's go to count. You have elements over here. Elements, I'll say displayed. Select the FA entities radio button and say selected. So once you say selected, you can see over here that you have got the number of nodes and elements. So simply you'll have to take the number of nodes and the number of elements from here and enter it under the number of nodes and number of elements column, and at the end you can just put on the stresses what are getting generated with respect to those respective problem statements. So this is how you can solve the problem by using 100 element size, quad element first order, 50 or 10. Now I'll just show you how you can change the order. So to change the order, I'll just delete this previous elements, return. I'll go to auto mesh. We'll select the surface, give the element size. Here you can see before it was first order. If you just go to the toggle arrow, it will create the second order elements now. And then I'll say mesh. So return. Now in this case you can see that the element shape is in the previous case in the first order it was in this way. Now in this case you can see that it has created a node over here also, just to capture the geometry in the more proper way. So this is the second order element. So it has created a node over here also, which is trying to lie on the geometry. So here you can see now that the geometry is getting captured in a more proper way. So if you just try to solve this uh, by using the element size of 100, second order element, you'll get the results which are more better as compared to the first order elements with the same element size and shape. So this is how you can change the order of your elements. And if you want to change the shape of your elements, you'll go to auto mesh, select the surface. Under mesh type, you can see that there is a drop down. So you can select the try elements, give the element size, keep it to first order or second order according to your problem statement, and say mesh. So these are the try elements which you can see over here in the problem statement. The third thing that we have is mixed. So let me say reject, return. If you go to the drop down, you have an option of mixed. Say mesh. Mixed means simply it will create quad as well as try elements. Reject. And if you go to the next slide, you can see that there are some more element shape, that is R tria. So for R tria also you can select in the same way the R trias and say mesh. So these are the R tria elements which are getting created. Yeah. So is this thing clear with everyone now? How you can solve the problem statement of plate with hole without using a washer? We have not used any washer. What do you mean by washer? That you have seen during the theory time, we'll be applying the same concept during the tomorrow's session in the plate with hole geometry itself, and we'll be seeing how you can solve this same geometry by using a washer. So today we have seen just how we can solve this problem statement without a washer, how you can uh, change the element size, the element shapes, or the element order, how you can see the number of nodes and number of elements, and how you can take out the results, and how the results are going to differ if you change the element size and the element shapes. So is this thing clear with everyone, whatever we have seen till now? Okay, so the thing is cleared. If you're having any doubts, you can ask to me right now, or else if you're not having any doubts, thank you very much to everyone for attending today's session. And if you're not having any doubts, you can start exiting the session, so that once everyone has exited the session, I'll just exit the webinar. I just have a small question. If you have checked the classroom, everyone has actually we have updated the classroom, so everyone has got the updates till the yesterday's class with all the material and all. Fine. So everyone has seen that till yesterday, till yesterday's class, all the material has been updated. Rajat has a question: how to change dimensions of a plate? Rajat, Rajat, you can go to surfaces panel, and here you can select the size of whatever size you're having the plate. If you're having a square plate, you can definitely change the size from here itself and create the plate. If it is a square, this is one of the way how you can create a square plate 2D. Rajat, is your query answered? Okay, you need for a rectangle. So in the same way, if you're having a rectangle, you can go to nodes. You can create four nodes. However, you're having the dimensions of your nodes, you can create. You can give the inputs for the coordinates for your nodes, and then you can go to lines. You have seen this option, that is linear nodes. So you can go to linear nodes. You can join the nodes and create a line geometry for that rectangle, and by using the surface panel which you have seen during the geometry editing type, you can select these options, the ruled option. So by selecting this option, you can create a rectangular surface geometry, surface plate. Am I clear with you, Rajat? Shravan also has the same question. Shravan, am I clear with you also? I've answered the question. Venkatesh has a question that what should be done if model is imported with more than 4,500 components? Yes, Venkatesh. So if you're having the components which, if you're having a geometry which has more than 4,500 components, you can simply organize your component and make it into lesser number of components by using the organized panel. So in tool page you have the organized panel, so you can simply use this panel and reduce the number of components in your geometry. Am I clear with you, Venkatesh? Okay, fine. So any other doubt to anyone? Okay, so all of them are saying that they have no doubts. Fine. Thank you very much to everyone for attending today's session, and have a great evening further. I'll be exiting with this session now. Bye bye. Bye bye, everyone.